Okay, so you're given your function and it wants dy by dx, so direct differentiation. Dy by dx, you multiply the power by the coefficient, so that's 3 times 1/3 is just 1, so x squared minus 10x plus 9, so that's easy enough. Now they're asking for the second derivative. That means the derivative of dy by dx. So d squared y over dx squared is 2x minus 10. So both of these easy enough. It then says, where are the stationary points? Now, stationary points are those points where dy by dx equals 0. So basically, we need to solve for x, where dy by dx equals 0. So this needs to be 0. So what values for x will make that 0? So just to make it clear, we're solving dy by dx equals 0 because it's a stationary point. Now, because it's a quadratic, there are going to be 2 points. So that's why they said points. So first, try to factorize that, because you can sort of tell it's factorizable, right? So because you've got a positive sign here, it means the 2 signs must be the same, either plus plus or minus minus. But because that's a negative, we know it's going to be minus. And it looks like it's going to be minus 1 and minus 9. Because minus 9x minus x will give you minus 10x. So when you have 2 things that are multiplied to give you 0, it means one of them has to be 0. So either x minus 9 equals 0 or x minus 1 equals 0. So either x equals 9 or x equals 1. Now, the question asked for the coordinates. So it's not enough to find x. You still need y. Now, the expression that links x and y is given here in the question. So you'd still need to replace x into this expression to find the coordinates for y. So for x equals 9, y would be, well, the result of putting 9 into that expression. So while I grab a calculator, one over 3 times 9 cubed minus 5 times 9 squared plus 9 times 9 gives you minus 81. So my first point is 9 minus 81. And my second point is 1. Now I'm going to substitute 1 in there and see what I get. And I get 13 over 3. So these are my stationary points. Okay, 1 will be a maximum, 1 will be a minimum. So 1 will be a peak like that, and 1 will be a trough like that. The last question says, show that this one is a maximum. And that's really helpful because they're telling you one of the answers. So in case you didn't know, you know that now one of these is x equals 1. And we found that, so that's good news. Now, if you didn't know that x equals 1, they're sort of giving you the answer. So how are we going to show that that's a maximum? So the key is knowing that when there is a maximum, then the second derivative, d squared y over dx squared, needs to be negative. All right, so you need to know that. At a maximum, the second derivative is negative. And at a minimum, the second derivative will be positive. So the second derivative is simply 2x minus 10. Oops, that wasn't a good idea. So the second derivative is 2x minus 10. So if I take that down there and say d squared y over dx squared is 2x minus 10, and I substitute my 1 into there, that gives me 2, take away 10 is minus 8, and that's less than 0. So you can say, therefore, 1,13,3 is a maximum. Okay, so we can say it's a maximum because the second derivative is negative. So show that the stationary point is a maximum. All you need to do is show that the second derivative when x equals 1 is actually negative. And that's it. That answers the question.